6.4 talks about inverse trigonometric functions and right triangles. Something that we're going to talk about again in chapter 5 in full details. For now, we're going to scratch the surface for what we need. So consider a unit circle. If you have a unit circle, it's a circle with a radius of 1, which means at any given distance, that's a 1. That's really the core of chapter 5. So, if I extend on the x at 0 degrees, that's a 0, and that's a 1, and that's a 0. On 90 degrees, or pi over 2, on pi, or 180, 270 degrees, or 3 pi over 2. And if I look at, if you recall, if I take a point, any point on the unit circle, if the radius is 1, this is x, this is y, what do we know? We know that the cosine of theta is the adjacent over the hypotenuse. In this case, since r is 1, that's simply x. And the sine of theta is the opposite over the hypotenuse, which is y. So here, we're literally eliminating the point xy and replacing that by cosine of theta and sine of theta. So x value is the cosine, sine value is the y. So every time I ask about the sine of 90 degrees, we can draw the triangle. If you look at the triangle, the sine of 90 degrees should be the opposite over the hypotenuse. But we have a problem. The opposite of 90 degrees is the hypotenuse. And that becomes a problem. So, anytime we're dealing with one of these 4 angles specifically, anytime we're dealing with the 0, the 90, the 180, or the 270, there is no such triangle. A triangle doesn't exist. So instead you use the points on the unit circle, and that will do it. So sine of 90, you go to 90 degrees, it's right there. Sine, we said, was the y. That will be a 1. The cosine of 90 degrees would be the x value, which is a 0. The tangent of 180 degrees is the sine of 180 degrees divided by the cosine of 180 degrees. And in 180 degrees, the sine is the y, that's a 0. And cosine is a -1, that makes it a 0. So anytime we're dealing with these angles, we should make use of the unit circle. And those are the 4 exceptions. In chapter 5, we're going to start with that. So this is not going anyway. Now, let's get the inverse idea out of the way. So, inverse is working backwards, which is not simple. It's a bit annoying in the beginning. In this section, we just need to use the inverse to find specific angles. So we're not going full blast. We're kind of using it for what we need. And when we go to chapter 5, we are going to go over that in full details. 5.5. So, if I look at the following triangle, I have 2 angles, alpha and beta. If I wanted to use trig to find the angle alpha, this is not a standard, this is not a triangle of 30, 60, 90 or 45, 45, 90. This is just a general triangle. So if I want to find alpha, I have 3 ways of finding alpha. I could say the sine of alpha is, and in this case, as far as alpha is concerned, Let me color code those that will make life a bit easier. If I'm talking about alpha, as far as alpha is concerned, this is the opposite, this is the adjacent, this is always the hypotenuse. So if I say the sine of alpha is 1 over the square root of 26, I could also say the cosine of alpha equals the adjacent over the hypotenuse. Or I could say the tangent of alpha is the opposite over the adjacent. If the sine of alpha equal a number, alpha, the angle, would be the inverse sine of 1 over square root of 26, or it'll be the arc sine. Both of those are the same exact thing. So here, the deal here is they get this notation from f and the inverse of f. Students start mixing that with 1 over. That's not true. That's why I personally prefer this notation. But it doesn't matter. Either way, if I want to know what this angle is, I could figure that out. I'll get my calculator out, and I'll take, I am in degrees, you could be in radians, it doesn't matter. Degrees, you could see it better. And if I go for inverse sine of 1 divided by the square root of 26, that angle is 11.3. 11.3 degrees. There. That's one way of doing the problem. What if you decided you don't want to use the sine, you want to use the cosine? Okay, well, guess what? If the cosine of alpha equal 5 over 26, that means alpha equal, either you're going to use the notation of cosine inverse or arc cosine. And those two are saying the same thing. And alpha would be what? Well, what if I use the cosine instead of the sine? What if I was to say, let's go for inverse cosine of 5 divided by the square root of 26? I'll get 11.3. Hopefully you're not surprised. And what if somebody said, forget that, I want to use the tangent? So I'm showing you all of these three so that you are confident that it doesn't matter what you use. Either you say that's the tan inverse, or you say it is the arc tangent. Again, arc I prefer more, but this book sticks with inverse notation a lot more. And alpha would be, and I plug that in my calculator, and what do you think I'm gonna get? Can you guess? Let's clear this. It's cleared. If I take arc cosine, arc tangent of 1/5, I'll get 11.3. Oops, that was radians, now it's degrees. There it is. So does it matter which of those three I use? Of course not. It makes no difference whatsoever. Now, let's say I want to find, let's say I'd like to find beta. I know it's 90 minus. Let's say I want to use a trig function. As far as beta is concerned, this is the opposite, this is the adjacent, and of course I could do all three, but I don't have to. Let's pick any one of them. Let's say you decided to go for cosine. Cosine of beta, there's beta, is the adjacent over the hypotenuse. So beta would be what? The inverse cosine of 1 over the square root of 26. And beta would be, if I go on my calculator now and say forget this stuff, let's find the inverse cosine of 1 divided by the square root of 26. 78.7. Of course, I could have said beta is really 90 minus 11.3, but I just want you to practice using these kind of the calculator and figuring out that it doesn't matter what you use. So, to sum things up, inverse sine, inverse cosine, and inverse tangent are angles. Anytime you see an inverse or an arc, that's automatically an angle. You should know that. So if I was to say, hey, solve you should know I'm asking you for an angle. Anytime I see an angle, I could set that equal to theta. Anytime. And the only way I can get an inverse if I reverse the steps and say I must have had the sine of theta equal 1. So sine of theta equal 1. Where does y equal 1 on this unit circle? It happens to be right there. The answer to this problem would be 90 degrees. So, I'll come back to that. For now, let's get this out of the way. Find the angle in degrees, round to 2 decimal places. Alright. How does that work? Now, of course, I could use Pythagorean theorem to figure out what this side is. I want to do the least amount of work. All what they want me to do is find the angle. Well, let's find the angle. I'm given an angle, beta. I'm given the opposite, and I'm given the hypotenuse. And I have a trig function for any combination, and between examples A, B, and C, I touched on all of them. So here, I want a trig function that combines an angle, the opposite, and the hypotenuse. I know the sine of beta is the opposite over the hypotenuse. So the only way to find an angle is to use the inverse. And there it is. I'm done. Unless it's a 30, 60, 90 or 45, 45, 90, I need to use a calculator. The inverse sine of 5 divided by 6 would be 56.44 degrees. 56.44 degrees. If I wanted to find alpha, I notice in this triangle I'm given the hypotenuse and I'm given the adjacent. I could use the cosine. The cosine of alpha equals the adjacent over the hypotenuse, which means alpha would be the inverse cosine of 1/4, and again, the inverse cosine of 1/4 would be 75.52. 75.52 degrees. Of course, I could find the missing side and use sine if I want. I could find the missing side and use tangent if I want. The point is, if I want to use the given information, I should be able to use any of the trig functions from the provided information. I have a trig function for each one of those. Alright, how about C? Let's go the other way. Okay, and here I'm given an angle, I'm given the opposite, and I'm given the adjacent. Well, which trig function combine those? Of course, tangent. The tangent of theta is the opposite over the adjacent, so theta would be the arc tangent of 4/5. and that would be 38.66 degrees. 38.66 degrees. And there it is. Now, find the angle between 0 and 180. The reason we go for 0 and 180 in this chapter, we're going to go for triangles, and we know an angle cannot be bigger than 180. And here we're going to discover something odd. If I look for the cosine of theta equals 3/5, well, I know what theta equals. The inverse cosine of 3/5. Theta would equal, and what would that be? Inverse cosine of 3/5. That is 53.1 degrees. It didn't specify. 53.1 degrees. Now, I do have to take into account where's cosine positive? Cosine is positive in quadrant 1 and 4. So, if I look at what they limited, they want me to look between 0 and 180. That's only quadrant 1 and 2. So since I can't be there, and cosine is only positive in quadrant 1, that's my only answer. I'm done. What if I go for tangent? What if I look at the tangent? Say, okay, well, let me do the same thing. Alright. If I look at the tangent, well, obviously, theta is going to equal the arc tangent of 2/3. And theta is going to equal arc tangent of 2/3. That turns out to be 33.7 degrees or 33.69, whatever you want. If they didn't specify, no big deal. I would also check and say, alright, let me see how this works. I'm allowed to be between 0 and pi. All students, so tangent is positive. All of them are positive in quadrant 1. It's positive in quadrant 2, but I can't be there because of the limitation. So, I'm done. That's all there is to it. And if I look at part C, what do I notice? I'm looking at theta equaling the arc sine of 1/7. Theta would equal inverse sine of 1 divided by 7. I'm getting that to be 8.2 degrees. 8.2 degrees. That's very good. And if I'm look at what they want, they're saying run this between 0 and 180 degrees. So you can be there. And if I work, I notice there's a problem or an exception. Sine is positive in quadrant 1 or 2. When you say the sine of theta is 1/7, so if I was to draw my triangles, for example, if I was to draw theta, I have two options. I could say, look, theta is right there. The opposite is 1, and the hypotenuse is 7. Or I could say theta could be right there. The opposite is 1 and the hypotenuse is 7. X is being negative or positive. So in this case, I wouldn't know which quadrant I'm in. I'm either in quadrant 1 or in quadrant 2. If in quadrant 1, I got 8.2 degrees. And if in quadrant 2, you always run to the x-axis, remember that? If this is 8.2 degrees, how do you think I'm going to find this angle? Wouldn't that be wouldn't that be 180 degrees minus the 8.2? 171.8. So here I have two options, and only sine gets that. Only sine gets the two options between 0 and 180. Between 0 and 360, each of those have two options, but since we're going to only be looking at triangles, then we're just going to be looking at 0 to 180 in this chapter. Now,